Hey, my name's Ollie. Welcome to my presentation on the Assessment 4 case study. So let's start with the introduction. So Lucy is a 30-year-old elite sprint triathlete. She's aiming to qualify for the national sprint triathlon after recovering from a patella dislocation where she also had surgery. So the aim of this presentation is to outline her first testing sessions to establish a baseline for her fitness and inform her training program. The tests selected are designed to assess her functional movement, strength, flexibility, and key performance metrics in swimming, cycling, and running. These assessments will help guide the development of a targeted, evidence-based training plan to ensure her successful return to competition. Physiological requirements of a sprint distance triathlete. Sprint distance triathletes require a balance of aerobic endurance, anaerobic power, and muscular strength. Aerobic endurance and capacity supports sustained effort over the race's duration and is the most utilised system for sprint triathletes. Anaerobic power enables high-intensity bursts during transitions and sprints. Muscular strength and endurance are crucial for efficient movement and injury prevention. The first part of the triathlon is the swim, and that's 750 metres for a sprint distance triathlete. Some challenges include the cold water, the waves, and navigation. Triathletes must maintain a steady pace to avoid early fatigue while reserving energy for the cycling and the running. The primary system used for this section is going to be the aerobic system, used for sustained effort over the swim duration. And relies on the aerobic capacity with some anaerobic bursts during the start and the finish. So the next two sections of the triathlon is the bike and then the run. The bike is going to be 20 kilometres and the run is 5 kilometres. The main requirements is going to be aerobic endurance and anaerobic power for these ones as well. Anaerobic power is really important for those bursts of speeds up hills, if there are hills, and also like sprint finishes. Neuromuscular coordination is important as well, and this is used for efficient muscle recruitment for sustained power, speed, and endurance. So utilising VO2 max values and testing VO2 max is important for triathletes. VO2 max values vary across swimming, cycling, and running. Swimming requires specialised training for high VO2 max, with minimal cross-training benefits. Relative VO2 max is more relevant for triathletes due to body mass impacts on running. Efficiency and economy can compensate for lower VO2 max. This understanding ensures Lucy's program focuses on a specialised swim training, accurate endurance assessment using relative VO2 max, and improved efficiency to enhance overall performance. Economy of motion in swimming, cycling, and running directly affects performance. And swimming economy can be improved without prior exercise. And cycling and running economy, well, these should be trained sequentially. So cycling economy after swimming and running economy after cycling. Physiological adaptations. Cardiovascular, metabolic, and neuromuscular. These are key adaptations that enhance movement economy. Percentage VO2 max is important as well, and this training intensity is often quantified as a percentage of maximal capacity, correlating with performance. Lactate thresholds must also be measured independently for swimming, cycling, and running, as they occur at different outputs. So, looking at the overview of the tests that we'll be conducting for Lucy, we're going to start with the functional movement screening. Then we'll do a flexibility test and a strength test. And then on session 2, we're going to be going through our 1 kilometre swim time trial and also our Wingate anaerobic test. And then on day 3, we're going to be doing the Bruce protocol, testing VO2 max on the treadmill. These tests provide a comprehensive assessment of Lucy's strength and fitness, targeting key areas of triathlon performance. The data from the tests will hopefully inform the development of a targeted training program, addressing both aerobic and anaerobic capabilities and ensuring optimal recovery and performance improvements. Session 1, we're going to be starting with the functional movement screen. So the procedure includes a series of 7 functional movements to identify weaknesses and imbalances. This will hopefully identify performance risk factors by evaluating body movement, flexibility, strength, stability, and mobility. It serves as both a preventative measure and performance booster, ensuring safe sports participation by addressing potential issues early. Regular rescreening helps fine-tune training, promoting athlete health and performance. This screen is particularly important for Lucy, seeing as she's just coming out of a long rehabilitation period. So it'll be really good to see where she's at and make some adjustments from there if needed. We're also going to be doing a basic flexibility test just to assess her range of motion in both the hamstrings and the lower back. And this is going to be done by just the standard sit and reach test. Flexibility is crucial for efficient movement in all the triathlon disciplines. Improved flexibility can enhance stroke length in swimming, cycling, posture, and running stride. Also, session 1, we're going to be including a basic strength test, which is going to be the 1 rep max squat. So this is going to be measuring her lower body maximal strength, where we're going to be adding gradual weight to determine her 1 repetition maximum. We do need to be careful with this one, considering her past injury, so this can be adjusted to a 3 rep or a 5 rep if necessary. But lower body strength is vital for powerful cycling and running, as well as swimming. Assessing maximal strength helps tailor strength programs and will hopefully improve her performance. So in session 2, we're going to be doing a 1K swim time trial. The purpose is to provide objective physiological data on swimming performance. We're going to use previous best times to estimate pacing from the years prior. We're going to start the test off with a push-off in the pool, recording times for each 200-metre split. We're going to record stroke rate on the 3rd lap and stroke count on the 4th lap of each 200 metres. And if we can, we're going to have some monitors for heart rate that are waterproof. We're also going to use video analysis if possible, recording the first and last 100 metres to help with technique review. We'll compare overall split times with previous tests. We can evaluate the stroke measurements and heart rate data for changes in efficiency or technique. So it can help identify if performance changes due to physiological or technical factors. We're also going to be doing the 30-second Wingate test. So this is going to be measuring anaerobic power and capacity, which is less necessary and used in a triathlon, but it's still going to be crucial at certain sections of a triathlon. So that's why we're going to be including this one as well. It's pretty much an all-out sprint on a cycle ergometer for 30 seconds. And the metrics is going to be peak power, mean power, and the fatigue index. We'll talk more about the 30-second Wingate test later. Cool, and finally, on session 3, we're going to be doing the Bruce Protocol VO2 Max test. So this is a big one, assessing aerobic capacity. It's an incremental treadmill test where speed and incline increase every 3 minutes until exhaustion. Purpose is to measure VO2 max, which is a key indicator of aerobic capacity and endurance performance. It will hopefully provide critical data for designing endurance training programs for Lucy. It mimics the progressive intensity athletes face in endurance events like triathlons. Scientific support. So this test has been widely validated and used in sports science for its accuracy in measuring VO2 max, and it consistently produces reproducible results across different populations and settings. So let's quickly talk about the importance of test order and spacing. So spacing the tests over the 3 days allows for sufficient recovery and accurate results. Starting with less demanding assessments helps establish a baseline without overwhelming Lucy, especially considering her post-injury. So this structured approach minimises fatigue, prevents skewed data, and also reduces injury risk, ensuring a comprehensive evaluation and targeted adjustments in Lucy's training program. Addressing underperformance in transitions. So if Lucy's having trouble in her transitions, some recommendations include transition practice. So just doing regular drills, incorporating specific transition drills into training. Simulations, so set up mock transition areas and practice under race-like conditions. You can conduct these tests quite often because they aren't going to be too intense. It's more technical. Gear organisation is a big one, so explain to Lucy, and she should know considering she's a world-class athlete, but you can still work on organisation and making sure the gear is set up as perfectly as possible for a quick access. Speed and agility training will be a big one. You can do things like ladder drills, cone drills to improve quick footwork, and short sprints to simulate the quick movements that will be needed. And mental preparation is a big one as well, so just encouraging Lucy to mentally rehearse the transition process in her head before the comps. Training recommendations for improving sprint swims. So we can look at video analysis for this one. We can record and review her technique to identify inefficiencies. Doing drills is going to definitely help in her sprint swims. So you can do catch drills, focusing on the arm recovery and entry. We can do single arm swimming drills where we can improve our stroke balance and body rotation, as well as kicking drills to obviously improve our leg propulsion and reduce our drag. Endurance training will be very important. Seeing as it's a 750 metre swim, we can be doing some interval training. So doing the short, high intensity intervals with rest periods. For example, like a 10 sets of 50 metre sprints at maximum effort with nice long 2-minute rests. Or we can do longer swims, for example, 5 times 400 metre swims at goal race pace with 1 minute rests. Another thing is important to practice and work on if she's having trouble with her swims or not improving as she likes is going to be doing actual open water training. So simulating what it's going to be like in competitions. So practicing in the open water. This will help develop her skills for efficient navigation and maintaining a straight line. Continuing on with some recommendations on how Lucy can improve her sprint swims. Strength is going to be a big one. So getting out of the water and focusing on her strength training, and doing activities that focus on the core and her posterior chain, doing activities like pull-ups, pull-downs, medicine ball throws and planks are definitely going to help. So strength training enhances the triathlon's performance by complementing sport-specific training. For swimming, upper body strength increases propulsive force, stroke length and speed. Alright, so I'm going to explain how to ensure valid and reliable data for the 30-second Wingate anaerobic test. So this test is gold standard for measuring anaerobic power and capacity, which is important for triathletes. We've got 3 key metrics that it's going to assess: peak power output, mean power output, and fatigue index. The test accurately measures anaerobic power, which is validated by high correlations with other anaerobic performance tests. A study example was Malone et al., who assessed the retest reliability of the wand in trained male triathletes. The findings showed consistently high reliability for 1, 2, and 3 bouts, with intersession and intersession ICCs exceeding 0.7. We perform an all-out sprint on a calibrated cycle ergometer for 30 seconds. It's going to measure those metrics. We need to make sure we ensure the same ergometer settings, environment, and test protocol is used for every session and test done on Lucy. We make sure regularly the calibration is always regularly checked and maintained to make sure that the accurate resistance settings are set. And motivation, we want to make sure we provide standardized verbal encouragement and provide feedback to maintain consistent motivation levels. The test is relevant for Lucy as it provides insights into her anaerobic capabilities, which are needed during the high-intensity transitions, starts and finishes in triathlons. By following the procedures ensuring the test validity and reliability, we can accurately monitor her programs and make informed adjustments to her training regime. In conclusion, this assessment plan for Lucy includes functional strength and sport-specific tests to evaluate her fitness thoroughly. The structured approach ensures accurate data collection and guides targeted training adjustments. By spacing the tests over 3 days, we ensure Lucy's safety, prevent fatigue, and obtain reliable results, laying a solid foundation for a successful return to competition. Thanks for listening.